All right. Hello, everybody. We're going to go ahead and get started. Today, we'll be doing the first lecture from Unit 3. Just kind of a big summary of what we'll be talking about today. We're going to be talking about how populations grow and how they're a balance of biotic potential and the carrying capacity set by the ecosystem. We're going to talk about K versus R selected reproductive strategies, and we'll go into some details about that. We'll talk about where animals kind of fall on the spectrum between R and K. And then we'll look at a few examples as well to kind of wrap things up. All right. So let's start at the beginning here. So Unit 3 is going to be talking mostly about populations. So when we look at a growing population, there are two factors that essentially play a role in the size of your population. The first one is going to be your biotic potential. This is essentially how fast can you reproduce, assuming that there is no limiting factors in your environment whatsoever. So things like food amount, water amount, plenty of space, all of those things are available. So the fastest that you can grow as a population, this is referred to as your biotic potential. It is very rare that organisms reach their biotic potential because for the most part, there are going to be limiting factors, right? There is no utopian ecosystem out there with unlimited resources that allow a population to grow uncontrollably. So typically what happens is when you have a new population, it will grow quickly at first, but eventually it will level off. And where it levels off is referred to as the carrying capacity. And the carrying capacity is essentially the maximum number of individuals an ecosystem can support for a species. So every ecosystem and every species will have different carrying capacities depending on the limiting factors that exist within that ecosystem. So when we talk about how quickly organisms approach their carrying capacity, or if they stay near their carrying capacity in terms of reproductive strategies, there are going to be two major methods for how the biotic potential and kind of sustainability of the population will work. You have K-selected species, and K-selected species tend to be organisms that stay around the carrying capacity because we often represent carrying capacity with the letter K. And then you have R-selected species, and these are species that are kind of boom and bust populations. They don't really stay steady at the K. They just fluctuate up and down depending on local environmental disruptions or changes. So let's talk about some of the characteristics of K-selected species. Usually K-selected species will have very few offsprings per reproductive event. So for example, a human on average will only have one child, 2 or 3 maybe if there's twins or whatever. But for the most part, it's just one offspring per reproductive event. Elephants are very similar in that way as well. They typically have one offspring every time they reproduce. Typically, K-selected will have multiple reproductive events during their life cycle. So for example, a human will reproduce multiple times before their life cycle is done. Typically, these organisms are larger with long lifespans. So it's just a large lifespans there. Because typically we have a lot of energy investment in these organisms, and you can't have multiple reproductive events unless you have a long enough lifespan to do so. And typically, since these organisms live longer, they are often going to be larger because they're going to slowly accrue biomass and energy over their life. Their population tends to stay near the carrying capacity, like I talked about here. So here we have the rhino, which is a K-selected species. So typically, it'll just kind of hover around the carrying capacity. You'll have little fluctuations of up and down depending on, different type of episodic or periodic changes. But for the most part, they stay pretty steady. Competition is often higher due to demand of resources per individual. So you're not going to have these boom and bust populations. Competition will always be high because you're always at this carrying capacity. So you have as many organisms as that ecosystem can support, all competing for the resources that are scarce because there are so many individuals already there. And also they tend to be more specialist species. They're not generalists. They tend to, have one specific niche that they fill, and they stick with that throughout their life cycle. R-selected are pretty much going to be exactly the opposite. R-selected have many offspring per reproductive event, and usually only have 1 to 2 reproductive events during their lifetime. Fish and insects are good examples of this. They have a lot of eggs, a ton of offspring is born, and So smaller organisms, typically with shorter lifespans, again, they don't have that time to really develop a lot of biomass and grow. So they're typically small organisms. They live for a few years and then die. Populations tend to be boom or bust. depending on if you are in a reproductive cycle or not. So if you look at this population curve here, you can see that they have reproductive, a ton of competition, a lot of death. And then it just kind of spikes up and down. We call this boom or bust. Typically, you have low competition per individual, depending on where you are. So if you're at these bottom crests here, this is low competition, troughs, sorry. And if you're at these upper crests here, well, you're going to have a lot of competition. So they kind of go through this weird cycle of brand new life and death. They tend to be generalist species. Since you have so many, they have a lot of different niches that they can kind of fill and take advantage of. And most invasive species tend to be R-selected due to their reproductive strategy. So you just get a few of these offspring in a new area. They have a ton of offspring. There's little to no competition usually, and then they'll outcompete any specialists in the area. So most invasive species are going to be R-selected for that reason. Now, most organisms don't fit into a neat category like 100% R or 100% K. Typically, you have organisms that kind of fall on the spectrum. So like an oyster, which will have 500 million offspring per year, is a stereotypical model of an R-selected. Chimpanzee, which reproduces once every 5 years, is a pretty stereotypical example of a K. But you have a lot of organisms in the middle that have characteristics of both. So you have like this frog and hare, which kind of follow both paradigms. A good example, as I said up here, is the frog, and this is the poison dart frog. So it does have multiple reproductive events and produces a high amount of offspring, which you can see on its back here. But it does nurture its young due to the high predator presence. So you have an organism here that has multiple reproductive events, like a K-selected species, produces a lot of offspring, like an R, and it protects its young, like a K. So it's got characteristics of both. So we can't always fit them into these neat boxes. It's more of a spectrum idea for these. Okay. All right. So here we have a table on zebra mussel and unionid mussels. Zebra mussels, I'll let you know, are an invasive species, while this is a native species. So you're going to be comparing the two and then seeing if you can identify some of those RK selected characteristics about the population. All right. I will see you all tomorrow.